Hello, everybody, and welcome to another episode of Learn with Jason. Today on the show, we have another Jason, Jason Mays. Welcome to the show. Thanks so much for joining us.
Yeah, thanks for having me today, and it's great to have double the Jasons on this show. So
It's
excited to see what happens today.
you remember Double Mint Gum when they used to do all the commercials with twins? It was like double the pleasure, double the fun. So it's double the Jason, double the fun.
Good
So
stuff.
so for those of us who aren't familiar with your work, do you want to give a little bit of a background?
Yeah, so essentially, my background's in web engineering. I've been doing JavaScript for like 16 years, which is pretty much half my life. So very familiar with the web technology stacks. But then I kind of went all full stack, so I could do both front end and back end design, UX, that kind of stuff, and that got me into prototyping. And for a good part of my career, I was a creative engineer, which is basically creating new emerging technologies based on like machine learning, augmented reality, that kind of stuff.
So
For our top tier clients.
I'm going to ask you some questions about this because I find it so fascinating. I think this is a term that I hadn't really heard until recently. There was another developer, Elric Ryan, who was talking about being he said creative engineer was his title. And so this is a role that I think probably a lot of people aren't aware of. That effectively your job is to get weird with code. Is that a good summation?
That was my job essentially, but yeah, basically get weird with code is a good description. I am the king of breaking things and then trying to reshape them into new forms. So I've submitted a lot of bug reports in my time, that's for sure. So but yeah, basically I got to like explore lots of different technologies and try and make new things that had never been made before with them. So maybe we can combine this with that to make X, Y, or Z, and that could tell the story of our customers in a better way. And all of this was, of course, with web tech because I'm a big JavaScript fanboy. And I like to push the boundaries of what we can do in the web browser. And of course, that led me to learning about machine learning, which is now my current role. I'm now the developer advocate for TensorFlow.js at Google. And essentially, that's a machine learning library written in JavaScript based on the original TensorFlow. Basically the same thing, but in JavaScript, which is really cool, as we'll see. That's where I am right now, essentially.
Very cool. Yeah. So I am really, really excited to see how this goes because I feel like there is just kind of unlimited potential here. We've done a couple episodes on machine learning on the show before. We've had Gant Laborde has come on, and yes, we've done we've put masks on people. We found faces and figured out like how to calculate angle and size and all that stuff so that we could put a mask so that the eyes actually showed up over their eyes, right? Like these really kind of fun things that we could do. And so what I think, and then I just did a show with Cassidy Williams. I think it was last week. Time is both very fast and very slow right now. So it could have, I would believe you if you said that episode was last week or 3 years ago. So we just did an episode with facial recognition using faceapi.js where we were reading the emotion. And so we could make a face at the camera and it would show an emoji to show like how we felt. It was let's see what we can get done knowing nothing about this software. And so it's very, very interesting to me to see all the different ways that you can use this stuff. Because it seems to range from, we can do things with images like find faces and you can use that for like anonymization. You can, pixelate all the faces in a photo. Or you can do what we did, something silly like putting a mask or a hat on somebody. But then you can do this sentiment analysis. You can do just these incredible things.
There's a whole bunch of stuff going on, and I've got the community trying to use a hashtag to share all the cool stuff I've been making. I've just been monitoring that every week, and I just get blown away by the creativity of the JavaScript community. And like I know some of the other advocates at Google, I wish the Python demos were as cool as the JavaScript ones. So it's great to see people from different backgrounds and not just academics and researchers starting to play with machine learning. And I hope that with TensorFlow.js, people can explore more and tinker around, and artists and musicians and creatives can start playing as well. It's not just for engineers and everyone else. So I'm excited about that.
Yeah, I do really love that whole kind of like the artistic approach like that you can do, especially when you hear something like machine learning or you start to talk about artificial intelligence. The first thing that you think is it sounds like science, right? It sounds like something that's very rigid and very exacting and very mathematical. So when you see the ways that people are using it to just be silly, I feel like I love that. I love that kind of combination of art and science and ridiculousness.
And like I always try and use a model in a way it wasn't designed to be used. Like I don't know if you've got time to show a few demos I created if you go to my Twitter or something, but basically
we can do that. Let me switch over to this view so we can do it. So here's your Twitter. Where do you want me to
You just go to the home my profile page. I've got one pinned tweet which is right at the very top of the Twitter account.
I have Chrome problems. Let's see. Everything is frozen, so I'm going to quit Chrome, and let's try this again. Okay.
Well, fingers crossed. Let
me quit everything that's not
pushing the Mac to its limits there.
I really am. I'm like putting a hurting on it. Okay, so let's open another window here, and I'm going to restore these pages. Good, that's what I wanted. So let's get these ones in here. And
fingers crossed.
Hey, there we go.
Hey, there we go. Good stuff.
Yeah.
So you scroll down to the first pinned post at the very top there. So this is the thing that really got a lot of attention when I first joined the team. It's my first, I need to learn how to use this stuff. So what I managed to do is make myself invisible in real time. This is happening all live in the web browser. And you can see as I get on the bed, for example, that the bed still deforms as I start moving around in the bottom image, and I'm completely removed from the scene. So it's not just a cheap effect where you're just pausing the background and then, hey, we're done. Otherwise, you could just do that with a single image, of course, without machine learning. But this is a little bit more advanced than that, and that is doing it in real time. And then the other thing I'd like to show, if you could go over to YouTube and just type my name and then clothing size estimation or something like that, it should pop up with the right result.
This one?
So yeah, that's the one. You might want to just mute it, but and then scroll ahead to like where I'm actually dancing around. Yeah, that beautiful music there. So basically, in under 15 seconds, I can estimate the various proportions of my body and then figure out like what size clothing I should be buying on those random brand websites. Because I don't know about you, but I'm terrible at buying clothes. I don't know what size I am and all that kind of stuff. So often I start with a problem in my real life and I try and like solve it with the technologies that I have available to me. And once this gets to the point, here we go. Yeah. So you can see I click on a button, I enter my height, and then it will use body segmentation, which is the ability to detect which pixels in an image belong to my body versus the background. And with that, I can then figure out the different waist measurements, inner leg, chest, that kind of stuff. And I just do a side profile and a front shot, and then boom, it gives me my results. And then I can do what I need to do, which is kind of nice. So
that's slick. Well, that's that's super cool.
I like making little fun examples like this, and that's basically my role. I get to make these cool prototypes and talk about them, and hopefully inspire others to go make some cool stuff too. So
very cool.
Good stuff.
Yeah. So I'm sharing those links in the chat. They'll be in the show notes as well. And now that we're switched over here, before we move to the next thing, let's take a quick second to shout out our sponsors. We have live captioning available on the show. It is made possible by White Coat Captioning. Thank you so much for being here today. We have Ashley helping us out, so thank you very much, Ashley. And that is made possible through our sponsors. We've got Netlify, Fauna, Sanity, and Auth0 all kicking in to make this show more accessible to more people. We really appreciate it. Thank you very much. So with that being said, if you want to see the live captioning, they're up at lwj.dev/live. You can see it happening here. And let's bounce over. Let's see. So we looked at this example, this is really cool. This like active camouflage. Yeah. That's the dream, right? Like we saw, this was in movies in the 90s where you could they would make people invisible through active camouflage. Right. So the future is now, right?
Inspiration. Totally. And we should maybe just switch to the community as well. If you put hashtag made with TFJS into the search box, you can just see all the wonderful things the community is making as well. And
Like
you
this?
can have just a quick scroll. Yeah, that's, I think I can't actually read it, but yes, that looks correct. There we go. And if you just go to like, I don't know, top or latest, but that's fine. You can see like these people making these really beautiful artistic visualizations. This one was just like a self-reflection piece where you walk up to the cam and you see your own face being made in like WebGL particle effects and all this kind of cool stuff. So this could be cool artistic installation. This one is super cool. This can turn any SVG character into an animation that is controlled by your very own body using our face mesh and pose estimation models. So you can see the lady in the top left there moving around. We're estimating her skeleton and everything else. This is all running in the web browser, and she can now join like a Zoom meeting or a Google Meet as a character. So you can have privacy when you're working from home. If you've got some, lots of people in the room, you can turn yourself into a character and have more privacy.
That is really, these are really cool. So I'm just going to actually
do. So like, it just keeps on going. There's so much cool stuff happening.
So in the interest of making sure that we're able to actually finish what we want to do today, I'd love to kind of jump over. So what we're going to be working with today is the JavaScript flavor of TensorFlow.
Correct.
Do you want to talk a little bit about, like, I feel like we've all heard the name TensorFlow, but I feel like it's, I guess when I try to think about TensorFlow, it seems like it comes up all the time, and I don't know what it does outside of like, if it's machine learning, there seems to be something that TensorFlow is going to do with it. So what exactly is it?
Yeah, so essentially it's an open source machine learning library, which basically means that it's got all the functions you could ever need to make anything you could dream of. You can think of the Legos of machine learning, all the individual building blocks that you can put together in whatever way you wish to make amazing things. And that could be things like object detection. It could be sentiment analysis, natural language processing. It could be whatever you dream up, even the generative stuff like GANs, the generative networks that can make images from various training data and so on and so forth. So all of it is possible using this library. And the original TensorFlow has two flavors of the library. There's like the low-level mathematical building blocks, and then there's the high-level APIs as well, which in Python is called Keras, and in TensorFlow.js we call it the layers API. But it's basically the same as Keras, and it gives you the high-level building blocks to then make things if you so desire. But yeah, it's using the library still requires some level of machine learning knowledge. It's not something you can just jump into without some understanding of machine learning. And that's why with TensorFlow.js, we obviously have the library. However, we've also made some pre-made models that are super easy to use and get started with to experiment with machine learning, even if you have zero knowledge in machine learning. And this is a great starting point. So yeah, here's some of the models we've got available. So image classification, object detection, and just to kind of clarify the difference between those two, image is a thing in an image or not. It's like a binary yes or no, whereas object detection gives you the bounding box as well. So it's a bit more advanced.
So image classification would be like that joke from Silicon Valley, the like hot dog, not hot dog. It's a yes or no. And then object detection would be more like, this is a photo, and it would say, in this photo, I see a book and a person and a chair.
Yeah, or it can show you where that hot dog is and how many hot dogs there are if there's like several in the image. Whereas the other one would just say, I don't know how many there are, but there's definitely a hot dog in there somewhere. So yeah, exactly. And then if you want even more power, you've got the body segmentation there, which we can just generalize as image segmentation. So if you want to segment the hot dog, you could then know exactly the pixels that belong to the hot dog.
So like, is this what you used for the size estimation demo?
Yeah, correct. Yeah, exactly.
And then
that's using the body segmentation model. Yeah.
This is the one that was for that SVG demo that we just looked at?
Yeah. Yeah.
Very cool.
So yeah, pose estimation tells you where your skeleton is essentially. So you could do like gesture recognition or something like this potentially by knowing your skeleton over time. You could do some fun effects with that. Yeah.
Very cool. There's a lot out here. This is very cool.
Yeah.
All right. Awesome. So what we were thinking, and I pitched kind of a silly idea, right? And I hope you're on board with it. But what I wanted to do is I wanted to use the object detection to make like a secret password. So in order to get to a page in a website, I want you to have to show the camera a sequence of objects. And so I picked up a couple things from around my house. I found a banana. I found a fork, and I found a book, right? And so I want my website to be protected by a visual password where I have to show in a given sequence a banana, a fork, and a book.
Sounds good. Yeah.
If I want to do that, I have this fresh glitch project here that let me share a link to it here, I think. Yes. So this should let y'all join and actually look at the code as we go. And there's nothing in this. Like, this is a very basic Hello World website. Some really basic CSS, no JavaScript, and just basically like skeleton markup.
Yep.
So
looks good to me.
How would you like to start?
So I'm going to pretend, so everyone can like follow along like the learning journey, if you will. I'm going to pretend we're completely new to this, and I'll start how I would start if I did not know anything about all this machine learning stuff. So the first thing I'd do, of course, is I'd head over to the TensorFlow.js website, and I know that I want to use object detection, right? So if we click on object detection under the models area, we can go through to our GitHub. It has a nice README that explains how we can get started with our object detection model. So under usage here, you can see that essentially we've got a bunch of script tags we need to import. The first one is going to be the TensorFlow.js library itself. And the second one will be the Coco SSD model. That's the name of the object detection model that we're going to be using today. So we should probably go ahead and add those imports to our HTML at the bottom before the closing body tag. Not in the head, in the closing body is probably best, because these things actually take a little while to load, and if you put it in the head, it's going to freeze your web page for X seconds rather than rendering all the wonderful things we can render in the meantime. So cool. So we have the script in there. So now if we jump back to the demo code in the website there on GitHub. Yeah, so below this, we can see that we need a test image. So if you've got an image available on your machine, maybe let's just add that to the Glitch website, and we can upload it to Glitch as well. And the important thing to note when you're uploading images is that if you are doing it on your own server or somewhere else, you do need to make sure that the cause headers are set correctly. Otherwise, you're going to have a cross-domain issue where JavaScript can't read the image to then utilize in some way. So Glitch is really nice because it basically sets the headers correctly for us when we upload things to their CDN. So that's really nice and makes life a little easier. But if you did this on your own website, there's plenty of tutorials on how to set those headers, depending what web server you're using and that kind of fun stuff. But yeah, go ahead and drag an image into your assets folder. And what's the big one?
This is a huge image. This was a mistake. Let me go to
the power of your machine here.
Squoosh.app, and we will make this thing smaller. So let's take it down to like 800
640 by 480 or something like that's probably fine. Yeah,
nice and small. We'll make it lower quality. It doesn't need to be a masterpiece here. That's 99% smaller. That seems correct. Let's do that.
Yeah, that was a large image. I think you'll be pushing your computer to the limits there.
All right. So here is
and do machine learning on that size at the same time.
Yeah, this is a much smaller image. So now I can copy this. I'm going to come out here.
Shove that in our page somewhere on the body. Yeah.
Banana. Okay. And then object classification with TensorFlow.js. And then, let's leave that glitch button on. That sounds nice.
Perfect.
Let's also look at the...
Yeah, gives you a live preview there. That's always good to see.
All right. I'm making the text bigger because it's not very legible. Let's see. I might do this in 2 windows just for the sake of making that easier to read. So let's take this style, and I'm just going to make the image. We'll go max width 90. Good. Good. Yeah, good enough.
Cool.
Actually,
Perfect.
if we just go 100%, I think the body will take care of that for us. There we go. Yeah. All right, perfect.
Nice.
So now we've got an image.
We've got a banana. Excellent. So if we head on back to the little tutorial code on GitHub there, we should see how we can now that we've loaded the library, we've loaded the model, we now need to use it somehow. So you can see here we've essentially got this Cocoa SSD.load, and this Cocoa SSD object is available because you've loaded the JavaScript that contains it.
Got it.
And you can, basically everything in machine learning land is asynchronous because things can take milliseconds to run, which in computer terms is ages. So everything's async. So that's why we're using the then keyword. So we're waiting for the model to load, and then we're going to basically call a function that will be passed the model itself, which we can then assign to some global variable or whatever we wish. So we can go ahead and just copy that code for now. And you can see on the inside there, we've also got model.detect. So once the model's loaded, we're going to call model.detect on an image of our choosing. So we're going to get a reference to our banana image and pass that instead, but the principle will be the same for other images too.
Okay. So let's walk through this line by line here, just to make sure that we understand what's happening. We're getting our image just using regular browser. Get image by ID.
Yeah, perfect.
That's not right. We want a query selector because there's
only
no
got
ID.
one image, I guess.
Well, there's also no ID on this image.
So no ID. Yeah, there we go. Yeah.
Query selector the image, and then this Cocoa SD model is the one that came out of here.
Correct. That's right. So
I'm going to close this
we've
for
imported that at the top there.
Yeah. So we get the Cocoa SD. We load it, and this is a promise so that we don't have to do callbacks or whatever. And then the return value is the Cocoa SD model. And then using the model, we run a detect function on the image. And then we get back our predictions. And our predictions, if I'm understanding correctly, those would be like, what's in this image? Where is it? What are the bounding boxes?
Exactly. It's just a JSON object. So many JSONs in this stream. But yeah, basically, it's just a JSON object that basically contains the bounding box and the class of the thing it thinks it's seen, its probability that it thinks it's accurate, that kind of stuff. But we'll print this out and we'll see the raw stuff coming back in just a second to the console. So we can then see what's going on.
Tainted canvases.
So basically, here's the fun thing about cores. So if you go back to the HTML here, you need to add the cross origin attribute to the image. Oh,
is it dash?
I think it's one word, just cross origin lowercase, if I remember correctly. Let me just double check that 1 second.
There we go.
Oh, you got it? Yeah, okay, nice, yeah.
And look at that, it thinks it's a banana.
Woohoo!
And it is 97% sure that it's a banana.
Awesome. And then you can see in there's also a kind of another object that gives it the bounding box. So there's a little thing you can expand there at the top called bbox.
Bbox. And not for beatboxing.
Yeah. Maybe we could do that if we're successful today. We can have a go at beatboxing. But basically, it's got all the XY coordinates that you need to then draw a rectangle around that should you so desire. So all that good stuff.
Nice. Yeah. So that's pretty simple. Like that feels pretty good to use, right? It's approachable. It didn't require us to do a whole bunch of setup. We just load the models. Now, I mean, the abstraction here is that like we have no idea how it's classifying these images. So, and this is where I think like, it can get a little murky because you're just kind of trusting somebody else's data and hoping for the best. So yeah, I think Tomas, the C in CORS stands for cry. I think that is correct. The CORS stands for cross origin
resource sharing.
Resource sharing. That's what it is.
Yeah.
And also thank you, Tomas, for the sub. I saw that earlier and wanted to shout it out. But yeah, so from here, what do we do next?
Right. So we've got the ability to recognize objects. And we should probably just clarify at this point that the Cocoa SSD model that we've just downloaded has been pre-trained on like 90 different objects, 90 common objects, things like bananas, things like mobile phones, things that people probably have around the house. And of course, if you wanted to train on your own objects, we can talk about that later. There's ways to do that. But for now, we're going to be stuck with these 90 objects that it knows how to classify. So hopefully it's going to recognize our books and what else did you have there? Forks and bananas. So those three objects hopefully are things that it will be able to recognize. Yeah, perfect. We've got all the objects as well. So the next thing we need to do, I guess, is we need to like, instead of using an image, we need to like access the webcam and get some live data coming back, because you can actually call model predict many, many times. And once the model's loaded, you can call it as many times as you like. And we can just continuously do that on the webcam stream instead. So
nice. Okay.
I'd probably recommend at this point, now there's no code here to show you how to do that. That of course is web dev stuff, getting access to the webcam. So what we probably want to do here is add a video element into the HTML, which is where we can then use the get user media stuff to render to later on. So maybe create a video tag and call it, I know, with an ID of webcam or something like this, so we can access it easily later.
Okay.
And because I believe in JavaScript these days, in order to do something like accessing microphone or camera, you need a button to enable it. So maybe we should add a button as well called enable cam or whatever you want to call it, I guess, just below that, just so we have something to click. Cool.
Okay.
Nice. So now I guess we've got all the basic stuff. We can probably head over to our script.js and start filling out some JavaScript. Cool. Actually, let's cut the code out of the HTML, then put that JavaScript code into the script.js. So we can just start working in there. Otherwise, we might end up. Yeah.
Okay, so I'm going to
have all our JavaScript in the JavaScript file. So.
Perfect. Okay. Cool. So that also means, I think, let's see, that's deferred. Do we need to defer all of these instead of putting them at the bottom? I guess we'll find out. So let's put that here, and then I'm going to come back out here.
Yeah, we might need to add another tag at the bottom to include the script.js.
Yeah, so I think it should work because we're deferring. So when you defer, it waits until the whole DOM is loaded, and because we didn't defer the TensorFlow stuff at the bottom, it would be loaded before the deferred script. We're doing some weird stuff here, right? So technically we would want to defer the TensorFlow scripts. And in fact, maybe we should do that just for the sake of just not confusing anyone later. We can put these up here and we can just mark them as deferred. And now,
as long as the TensorFlow stuff gets loaded in order and before the script.js, then we're good. Otherwise, you're going to get errors about TensorFlow is not a thing, and
so we're in good shape here. So now what we're doing is we're doing a deferred load of everything, starting with TensorFlow, then Cocoa SD, and then our script. So here we are in our script. I have a let's double check this one more time. So we have our image, which I'm actually going to drop this image out.
Yeah, we don't need that anymore. That was a good test. But,
and then that means that in our script, all of this will break if we don't comment it out because there is no image to test.
Correct. For now, yes. We'll get back to that bit in just a little bit. Let's add the webcam in first, I guess. So maybe we want to just style that video tag so it's got some width and height so we can see it on the page, and then we can see stuff rendered to it or something.
Okay. So let's give webcam a display.
Maybe 640 by 480. I think that's a standard webcam resolution. That's good enough.
Yeah. So aspect ratio doesn't work yet, does it?
Oh, that's a good question.
We'll go height 0, and wait, we need a container on this. So we'll do like a div class responsive embed, and then we can put the video inside of that.
Nice.
And our responsive embed is going to will be, that's already display block, but we'll make it position relative. We'll make it a width of 100%, a height of 0, and a padding bottom of, let's see, 16 divided by 9. No, 9 divided by 16, 56.25%. Okay. And then nice. We can set the background to be red so that we can for sure make sure that worked. There it is. There we go. Yeah. My favorite my CSS debugging technique is always.
It's always good to see how others do their CSS stuff. Make sure everything works correctly.
Top, left, right, and bottom of 0. And that will give us, I think we can set a background of blue on this one. And that should give us, oh, what's going on?
Wait.
Did I typo something?
I think, oh, there we go. Okay.
Why isn't this?
I think you need to have the parent to have a position as well in order for the child to respect it, I think.
Yeah, that's position.
Oh, there it is. Sorry, my eyes are not working today. Okay.
What aren't you? That's
okay.
Odd. Okay, whatever. We'll just use that. So we'll go top left, and then we'll go width 100%, height
cool
100%. Not quite sure why that's working, or why one is working and the other wouldn't, but I'm sure it's something silly that the chat will point out. Okay. Excellent. Good. So here we go. We are ready with a bounding box. We don't have anything on it. Maybe we can just give it like a border so that we can see it. There we go. So that's where our webcam should be.
Cool. So I guess, the next thing to do then would be to get access to the webcam using get user media.
Okay.
So if I remember correctly, essentially it's navigator.mediadevices.getUserMedia camel cased. And that actually takes an object as a parameter, I believe. So we need to make an object above that with the constraints. So I think we just make a constraints object with a property of video equal set to true. And I think that would make us just get the video only. We don't need the audio. Yeah, cool. I think that will get the...
Okay, so that's allowing... But we're not doing anything
just yet. So what we need to do is we need to use a .then, because that returns a promise now, I believe, in the new spec.
Okay.
So we do .then on that, and that's going to pass us a stream object back. So to whatever function we pass there, and we can then set the video.src object with capital O to the stream that gets passed back, essentially. So get reference to our video object, and then we set its src object.
Like that?
src, actually the word object at the end of src, so capital O. Yeah, cool. And then make that equal to the stream that got passed back. Yeah, that looks good. So now we just need to enable it. Is that in a function, or what have we do there? No, that should be asking you for permission right now.
And it shows me that my webcam is on. We are HTTPS.
Okay.
Let's check for errors. What did we get?
Yes, yeah.
Nothing.
Always good. Okay, no errors. That's okay.
Check the video.
And your webcam is available in the Chrome thing at the top right there, right? So, whoops. Yeah.
I'm gonna check the get user media real quick just to make sure. So we get a stream, navigator, media devices, get user media. That all worked. And then with our stream, we need to put it somewhere. Video, true, good, yeah.
Yeah.
Okay, but show me how to put it into a video tag. Really? You don't have a single demo? Come on now. Examples. Here we go. Video source object is media stream. Video. Yeah. Oh, we got to tell it to play. And so I think we actually might be able to.
We can just set autoplay or something on the tag, right?
Yeah, I think that just works. There it is.
Yeah.
Good.
Yay! We've got the video.
Look at it go. Oh, I just realized I didn't turn this. I was supposed to turn this thing on. What kind of production am I running here? Look at that. It's beautiful.
There we go. Now we've got all the lights.
Oh, look, now you can see this side of my face, which was before lost to the shadows. Okay. All right. So now we'll be able to. So this is the stream, and then this is my computer. Yeah. So I'll be showing to the computer.
Bananas like this, exactly. Yeah.
Right. Perfect. So we'll basically be playing this game. All right. Exactly. So good. Now that is a good question. So just to prevent any issues later, I'd recommend also when we add the when we set the source object, we should add an event listener for when the video is loaded. So I think loaded data is the event we should be listening for. And that's what we can use to then start calling our machine learning to start predicting the webcam results instead. So that way we know the video stream is working, because I've had problems in the past where you start trying to predict things on a blank video stream and basically everything blows up and it's not too good. Yeah. And that was what on loaded
I think that the event to listen for is loaded data or lowercase, one word. So add event listener. Yeah.
Add event listener.
Yeah, and then the first parameter is a string called loaded data, one word lowercase. Yeah, and then we just pass a function we want to call after that. So this is going to be where we're going to start activating our machine learning kind of prediction loop, if you will, whatever that will be.
So do I just want to get straight into this thing, or?
Yeah, we can probably just copy the Coco SSD stuff we had from before. So the load stuff we should have loaded before, actually. Okay, we can do it here. It's fine. Yeah, let's do it here. That's fine. Yeah.
Okay.
Cool. So yeah, do exactly what you had before and just paste it in there for now. And then once it's loaded, we'll call like our animation loop or something, which can be a separate function, which you can then just.
In this case, am I running it against the stream or the video, or what am I running it against?
Yeah, it'll be the video tag itself. So we have to get element by ID or something like that. If
Got it.
Done that
yeah,
already.
I abstracted it out here so that we could use it again.
Perfect.
So I'm going to get that, and then we'll get predictions.
Correct.
And with those predictions.
Log those for now, I guess. Yeah.
Okay. So that should give us our predictions. Good.
Fingers crossed.
Excellent.
If we run that now, it'll probably say person because it does recognize people. So it'll probably see you there at least for now. And we'll see what pops up.
It does. It is 86% sure that I am a person.
That's good.
The other 14% is what? Bear.
Who knows what you see? Maybe some other things in there too.
Okay. So now we need to set this up. 14% beard. That was the right answer. So I want this to not yell at me. That should still work. It doesn't. It does? It doesn't. No, there it is. Okay. No. Good.
Oh, there it is. Yeah.
Yeah.
It takes a few seconds, depending on your internet connection, to load the model and the refresh there. But yeah, basically, good stuff. So yeah, we've done it for one frame. So we need to make an animation loop. Now that we know that we can call model.detect in that area, what we should probably do is create a separate function, a named function that we can call repeatedly on the webcam. And in there, we'll just take our model.detect code. And instead of calling model.detect below, we'll just put that code above and call this function once it's ready. Yeah, perfect. Nice. So that should lead to the same result. But now, of course, when we finish a prediction under detect, we can call detect objects again, essentially.
So what you're saying is like window request animation frame. And then we would just run detect objects model like this.
Sure. Yeah. I mean, I guess the request animation frame should be in the looped one above. The first call can just be a regular call, but the request animation frame should be in the function you just made above, which will be looping forever.
Oh, I understand. You want it to call recursively. I get it.
Yeah. Cool.
Yep, that works for me. So then we need to also pass in the video. Yes.
Cool.
Good. Okay. So that gives us our loop, and we should be getting...
So theoretically, we should get a whole bunch of stuff coming out once the model loads. Oh, what does that say?
Property detective undefined. It dumped our... Oh, that's just me not doing it right.
Here we go.
So this should just give us a very fast stream of...
Exactly.
There we go.
Hey, boom. There we go.
And so each of these is going to be right now like a person or whatever, but then check this out. Watch. Okay, so our most recent one
let's go
says
down there.
banana.
Hey.
Okay, and now it's gone. So let's grab one from down here, and it'll say person. So as we move things in and out of the camera, it should change what we see, which is pretty awesome.
Exactly, and it's got multiple objects. It will just have an array of things that it's seen. So what might be useful at this point, just for debugging purposes, is to maybe write out to a paragraph tag somewhere else on the page what we're seeing instead of having to look at the console all the time, and then we can just kind of like in real time see what's coming back.
So we're not actually using this, so I'm just going to drop it. And let's instead show the current model. And so what I'm going to do instead here is I'm going to document.query selector. We should call that current predictions. And then we can set the inner text to be JSON stringify predictions null 2. And I think what that should do is replace everything inside of it. We'll call this current predictions. Perfect. And what we should see, hopefully.
Where is it?
There we go. So here's our ongoing classification.
Beautiful.
So I showed a banana. Oh, and it says it still sees a person in the background. But if I hide my face,
objects, which is cool.
It will get rid of me. And then let's show it a fork. Can you get fork?
Maybe a little closer.
Fork.
Hey, there we go.
Right?
Good stuff.
And then if I show it a book, this is a great book, though, by the way. It's it's on the history of punch. And then this is book. It's like 50% sure this is a book. Close enough to get us there, right?
It's good enough. And that's the other thing as well, like the score it gives back, we as programmers can decide if we're going to allow like a certain threshold or not. That's our choice. So if we are trying to recognize a cat, maybe we're making like a pet feeder, we're 100% sure it's the cat, then we're going to give it the treats. Otherwise, we're not. So we can decide what a good threshold is, and
that's
we can do the same
cool.
for this experiment too. Yeah.
And hey, welcome Auth0. Auth0 just showed up with some friends. What is up, everybody? What were y'all working on today? What we are working on is we are using TensorFlow.js to build a visual password. Right, we're going to protect some content by requiring people to show some objects. And so I did for funsies. I did some drawings of the things that I wanted us to look at. So here are some drawings of a banana, a fork, and a book that we can use for this demo. And so what I was thinking would be kind of fun is like, I think we can do this pretty quick and dirty, right? Like we can show the password that we want, and then we can do that, I guess, in like random order. And then as
math.random.
Yeah, right. And we'll just shuffle the array and have those 3 images, and then we'll show them in whatever order. And in order to get to the next phase, you have to show the 3 items in sequence. So if I'm thinking about this correctly, to just kind of pseudocode this out, let's see, we're done down here. To pseudocode this out, we need to, 1, show the 3 images in a random order. 2, we need to tell, or like know which image is next in the array. Let's see, mark an image or mark an object as seen when it's detected, and then show secret content once all 3 images or objects are detected. Does that seem...
I mean, that's basically the gist of it, I think. And the only thing I'd add there is that if we show an incorrect object, it should reset itself. Otherwise, we could just brute force.
Well,
just keep showing bananas and things, right, until it gets it right.
For this demo, given that we are somewhat haphazard with the order of things, and like that we're getting multiple objects back and stuff, I'm a little worried that the reset's gonna get us in trouble. True, so I think in this case we should allow brute forcing.
Okay.
But
a fun activity for one more thing is to make it more secure.
Yes. If you were gonna take this further, you would want some kind of a brute force detection, right? Like multiple wrong attempts would need to reset or something. But the problem is that if I show, I pick up a banana and then I put it down and detects person, it would reset the whole thing. So that would be...
But we can allow person. Maybe person is like
interesting,
kind of... Because we also need to detect, because remember how fast it runs. Like we're looking like 30 frames a second here. So if you hold a banana there for a split second, it's going to count 3 bananas instantaneously. So I think we want to recognize an object that is not a person, and then we want to specify a state in the system that it now needs to look for only a person. So that means the person's put the banana away, and then the person can present the next object. So I think we need like a state system going on too, to make this it's running so fast. That's the only reason we need this. If it ran once a second, human could deal with it. But I think because we're running so fast, we need to kind of have that state system in there too. Mm-hmm. But let's see how it goes. We can get to that as we go along, I guess.
Yeah. So what I'm going to do for now is I'm going to get an array of our objects here. We've got a banana, we've got a book, and we'll do one more, which will be our fork.
Nice.
Okay. So I'm going to, this one. Put this one in here. And so now we've got our objects. And so what we need to display out here is a password. So we'll create a new div and we'll call this password.
Cool. Yeah.
And I think the way that we want this to work is we'll basically inject 3 images in here in whatever order.
Sure. Yeah. Sounds good.
So let's create a function.
Yeah, password generator, good stuff.
Yeah, generate password, and this is going to let's see, what's a good like object shuffler?
I mean, I would just use math.random on the index of the length of the array or something like that.
But we need it to be like we can't use math.random because we'd have to like track everything. I'm wondering if there's just like a fast way. This is the very...
Oh, just to shuffle the array automatically. I see what you mean.
Yeah.
Okay, yeah.
Shuffle the array in place. I don't know. Should we just copy paste from... I think maybe we just copy paste.
Are they using math.random in that actually? That's interesting. So yeah, basically I think either way, it's in there somewhere, just but we're not using it directly. Yeah.
But how are they doing that? Because wouldn't that... I'm confused.
Let me have a quick look as well.
Destructuring assignment. Oh, don't implement it on the prototype. Don't do that. Interesting. I'm somewhat confused by the choices here, because if it starts with the length of the array, then wouldn't is it popping the array item off? Oh, it's swapping.
It might be.
It's swapping.
It's swapping them around there. Yeah.
I get it. I understand. Okay, that makes sense. So it's basically doing a shuffle in place. I get what's happening. I'm going to copy paste this directly from Stack Overflow because that's what senior programmers do. And we'll just let's see. We'll just add a link. Okay. So we have a shuffle. And so we will start by, does it return that array? It does return the array. Good. So I'm going to say password equals shuffle.
Yep.
Objects.
What do we call that? Objects. Nice.
Okay. And then we will do a password for each. That's going to give us an object, and then for each object, we are going to, let's see, we also need to get our
into the DOM.
Equals document, query selector. Call that password? Yes.
Yeah.
So we've got our password. And then what we're going to do is, let's see, image equals document, create element image, and then we'll set the image.source to object.source and the image.alt to object.alt. And then we will container.append child image, and we also need to empty. There's a way to do this that is. What do? You're like
you trying to reset the.
Yeah, I just trying to empty it out.
You can just do like .innerHTML equals nothing, and it's a bit naughty for XSS injections maybe, but as we're setting it ourselves to nothing, it'd be hard to hack, I guess.
That's fine. Okay, so let's do that, and then let's just give it a shot and see what happens when we run it. Okay.
Nice.
Run it again. Yeah. Do we get a different order?
Yeah, let's see. Book, banana.
Heyo.
Yay, there we go.
Look at that. Okay. So let's make this look slightly easier to deal with. So we'll go with a password. Will be display flex, and we'll do what do we even actually, why don't we just do this? We'll make it grid, and then we'll go grid template columns repeat 3 1 fr, and that should give us a beautiful password. There it is. All right. So now, no matter what we do, we should be looking at a randomized password. Good. Okay.
Yeah, nice.
We also don't really need to show the webcam, but I think for funsies we can. And then I think the other thing that we should do is we should say like password dot or password image should probably be like opacity 0.5.
Right. Yeah, and then we can set a class when it's been activated or something to make it show that we got it right. Some nice visual feedback.
Okay, and then we can transition that. Transition opacity. We'll go like 200 milliseconds and linear. Okay, so now we have, I think.
Yeah, the page reload can.
Yeah, look at that.
There we go. Perfect. Nice.
Okay.
Nice.
So what we don't have here is we are not currently tracking anything about the given password. So I think what we need is we should also like return our password so that we can use it.
Yes. Yeah.
Okay. And then what we
That's what we'll use, basically. Yeah, that makes sense.
Okay. So now that we have a password, what we want to do in here is when we're detecting objects,
Yeah.
we want to be looking for the next, like the next item in
we need a password index or something to know where in the array we are, like how far along the chain we are in the array, and then we can just check the nth element each time for if it's a match.
Okay. Yeah.
Yeah.
So we can let's see. Thinking through this logically, we have the current object would be 0 to start, if I can spell.
Yeah, correct.
And then we would want to...
I think that's all we need there, no?
Yeah, so do I need to set this
We
up?
just increment that every time we find the correct item in the loop above. We just increment the counter, and then it will automatically go to the next thing we need to show, right?
Yeah, so then I need to put this like up here.
Yeah,
and so
sure.
when we're searching, we're going to say if predictions
I think it's class. Yeah,
hold on.
Yeah, predictions and so there could be more than one prediction, as we saw. So we do need to go through. We do need to iterate through all the predictions. Yeah, let's look at that object again. That comes.
So we're going to get an array of objects, and so we're looking for. We can just find for class of whatever the first object is. And then we can check if the score is over what, like 70%, you think?
I think let's go for 66, 2/3.
Okay,
and just to be safe on the safe side, that should be fine. Yeah.
Good. Okay, so if we do predictions, let's see. Match would be predictions dot find, and I'm just going to shorthand this, and we'll say password. I'm gonna move this whole password thing up so that we can actually. Okay, so let's just move this whole thing up. This is definitely like janky code, but we're gonna deal with it. So if password
so
current
we need
object, right? Password current object dot
dot
alt,
and what's the name of it?
Equals
cool, alt.
P dot class. Was that it?
Dot class, yes, correct.
Dot class.
Oh, class name actually. Is it class or class name? I've forgotten now. Sorry.
Class.
There we go. Oh, it's class. Yeah, cool.
So if we get a match, if match, then we will current object increment. And we will say
we should set the class of the one we just matched to be visible as well.
Yes, and the way that we're going to do that is by saying document query selector. We'll just hack this. Alt equals match.class. And then we'll say class list add, and what did I call this? Found.
Cool.
Okay, so theoretically speaking, this should work. So let's wait until we get our thing here. Okay, so there it is. So when I show this a banana, we should see that banana fade in.
Yeah.
Oh my God, look at it go. Look at it go. All right, let's show it a book.
Oh my gosh.
Book, and
okay.
Show me a fork.
Third one.
Oh, that is beautiful. That is beautiful.
Well, but it doesn't matter. It got there. Oh, yeah, of course, it went out of bounds at the end. We can just tidy that easily. That's fine. Yeah.
Okay.
Cool. That's nice.
Oh, I guess what we could do too is we could even say like if current object is greater than,
or equal to length, right? Equal to length. Yeah.
oh, that's right. Yeah.
Yeah.
Or we would actually want it to be
congratulations message
less
or something.
than. So we can basically kill this loop once we have hit the thing. And then for now, we can do document.query selector current predictions inner text.
Nice.
Unlocked. Okay, so this is like the jankiest of jank, but I think this works, right? So what we should be able to do now.
Yeah. Yeah.
Okay, banana.
Nice.
Fork.
Yeah. Good.
Book. And we're unlocked, and the loop is done. We still got one wrong. Aha! Behold, my bucket. My bucket. Oh, wait. If match, alt. Why is it giving me an alt issue?
Sorry, what was the error? I didn't quite see the error there. My bad.
Password current object. So the error is that it's missing a, when we get to the top, so we showed a book.
Yeah.
Come on.
Oh.
We showed a banana. And we showed a fork. And then it tries one time to get an object that doesn't exist, which means that the alt is...
Oh.
So this is the alt that is trying...
Something's calling it. I see.
Oh. So we need to...
But how is it called again when we're not...
I know what it is. We need to be checking up here. So if... Then we will do this. And return. And then down here, we'll just keep this as it was. Okay, so this should actually work. So effectively what we're doing now is we're saying, when we get our predictions, check to see, oh, Stampede, here we go, corgi time. I still haven't added the sound back in, so I apologize. We'll get a good parade going one of these days. But so what we're doing here is we have the model being detected, and then once we get our predictions back, it checks to see if we've already gotten the whole password. If we've already gotten the whole password, then we set it unlocked and we return, which bails on this whole function. We're done.
Yeah.
If we're not there yet, we get a match by looking for whether or not one of the predictions matches the next object in the current object. So the alt text matches the class names, which is why this is working. If we get a match, then we set the matching class to found so that it fades in, and we move to the next item in the object, and then we start the whole loop over again. So what we were doing wrong before is we were doing the increment, and then it was running the loop one last time.
But it's already incremented, so it'd be out of bounds, of course. So
now this should, let's see, if we did this all right, then what we'll do is we'll get our password in.
Nice.
Look at my fork. Come on.
Yeah, fork is like kind of blending with the background. So
okay, there it goes. Nice. Got it. Okay. Yeah. And a book. There we go. Yeah. Unlocked. Hey, no error. Nice. We have done it. So that's it, right? That's the thing. And so y'all can go try this right now. Beautiful. I'm really excited. We're also like surprisingly ahead of schedule here. This
I've got something I can
way to go,
show you, which could be good to if we got a better spec. How much time do we have left? What's the timing at?
We have about 20-ish, 25 minutes.
Well, I'm just going to throw it out there. Like, there's a really easy way to take 5 of those minutes up to show you how to recognize any object in the world in 5 minutes.
Let's do it.
In that.
Yeah, let's do it.
So if you go to your favorite search engine and go to Teachable Machine, you should find a website called Teachable Machine. I believe it's .withgoogle.com, but just in case I got it wrong.
Teachablemachine.withgoogle.com. Okay.
Yeah. Now, this is actually powered by TensorFlow JS as well. And the only difference here is that we're using TensorFlow JS for its true nature to actually create machine learning models using training data that we're going to feed to it live from the web browser. And what's really cool here is that all the training data we're going to give it is never sent to a server. So all your privacy is also preserved as well, which is nice. So none of this data we're going to use for training will ever be sent anywhere. So click on Get Started at the little blue button there. And currently, you can see when you click the button that it supports 3 things at the moment. Hopefully this will grow with time. We can detect objects, we can do audio, or we can do poses. Just to iterate on the object stuff for now, we go to images, but we can look at the others in a minute maybe if we have time. But basically, let's go to images for now, image project.
Okay.
And you get this really nice interface. So that we got basically on the left-hand side, this is like the 101 of machine learning. You have a number of classes you want to learn how to recognize, essentially, okay? So we need some training data of each class. So I don't know what you got over there, but if you've got some interesting objects that you are pretty sure it's not going to recognize, feel free to grab it. Maybe it's your face versus something else. We can do that. We can recognize you versus some other thing, maybe. We can just name the class whatever you like there. Click a little pencil icon and give it a name for something meaningful. So whatever you have around.
I have 2 watches. Is that a good one? Maybe.
Possibly. Are they different? Are they the same?
They're different. They're different watches, but they're wristwatches, right?
Okay, as long as they look visually different, then you should be able to detect the difference. This is very risky. I've never done this before.
See what happens, right?
Let's do it. Let's just try this. So class 2, call this like whatever you want to call the other watch. Yeah. Other watch, yeah, why not? Okay, so click on webcam for the first watch. And what we're going to do is we're going to allow access to the webcam, then the pop-up.
Okay.
Now you've got a live preview of the webcam data coming in. Now hold your watch up to the cam, nice and close-ish, not too close, but so it's visible and you can see the detail. And now what I want you to do is, in a minute, once I finish talking, click on the hold to record button, but move your hand around the scene just so you get variety of angles on the watches a little bit. So just move it around,
like just kind of like this.
30 samples. You'll see the samples pop up on the right in a second. So hold the button and just move it around. Good, done, perfect. That's plenty. Yeah, whoa, loads of images. So that's good. So the more images you use, the more time it takes to train, obviously, just FYI. But basically, you now click on, go to the other watch and do the same down there and try and get the same number of images of the other watch. So 80, I think you had. Get roughly the same. That's important. Good?
Almost perfect.
That's close enough. So now we can click on train model in the middle there. And what's going to happen is going to do something called transfer learning. And what that is that we've got the Coco SSD model that already knows how to understand various objects in the world, like 90 of them. And it's learned something about the world by learning those 90 objects. It knows how to detect edges. It knows how to detect certain shapes and so on and so forth. So it can use that knowledge now, try and recognize other things. So now if you bring up, now obviously it thinks your watch number 1. And this is the other thing to point out about machine learning. Bring it closer. There we go, good. So watch 1, and now bring in the second watch. And you have to bring it to the same kind of closeness you had before. And visually, watch 2 is now predicted. So it does indeed detect the difference between those 2 watches. And we did that in 30 seconds?
Yeah.
And you can actually click on the export model at the top there and select TensorFlow JS. And we can then use that on any website we wish to maybe unlock your website with your watches instead. So you can do
that's cool.
Like.
Yeah, that's super cool. I like that. But yeah, I love the approachability of that, right? Because and the thing that I also really like about this is that one of the things that we talk about in training data is always bias, right? So with something like this, you can bring your own data set and you're able to do, you can help ensure that whatever the thing you're trying to do, you train a model that way. And like, obviously with a real data set, now I'm going to take a wild guess here and you can correct me. In say like the object recognition model, I'm guessing that we're talking tens of thousands of images that got trained. Is that
for each object? Just imagine for a second we wanted to recognize cats, right? Mm-hmm. In order for the machine learning to best understand what cat pixels really are, we need to understand kittens versus adults. We need examples of both of those. Different fur colors, different fur patterns, taken at different angles, in different lighting conditions, in different environments, in the grass versus in your house. All that kind of stuff matters, because otherwise you can end up with bias in the model. So for your watches right now, for example, if we kind of only showed those two watches, if we show a bright blue watch, it might just think, well, that's not a watch. So we need like the variations to kind of make it learn that there are differences in these things, and color doesn't matter. It's more about the shape that's important here, or something like that. So with enough training data, you can get to that level of accuracy, essentially, that we can detect and generalize better. And of course, Teachable Machine is great for prototyping. Like, I've seen people use this to control their garage doors. So if they've left it open and it's getting dark outside, they connect this to a Raspberry Pi via WebSockets, and then it can shut it automatically and all that kind of stuff. So the possibilities are endless, what you can do with this. But for prototyping, this is great for things that you have at home and all that kind of stuff. But if you want to make something that's production ready, you can use something called Cloud Auto ML that allows you to upload gigabytes of data, and it will go away and churn for hours on the servers of Google, and then it will give you a model that you can export to TensorFlow JS at the end. So it does support TensorFlow JS. Is this
the one you're talking about?
Yeah, that's the one. No, not Auto ML. Cloud. Oh no, this is one. Sorry, I'm talking nonsense. This is the one. If you scroll down, there's an image classification one somewhere there, and essentially, you can see it talking about it. AutoML Vision, there we go. So basically, you upload your folders of images, and you can upload like gigabytes of data in each one of those folders, and it will go away and churn for days or hours, however long it takes, and it will produce a model that it thinks is the best. And what's really cool about this is that it will search different types of ML models. So we were using like Coco SSD or ImageNet, for example, but there's other things out there that exist too. And Google will try all these different models, see what gets the best performance on your data. So depending what type of data you have, some things might perform better or worse than others. And it will try and tweak some of the parameters you can set to refine things too. And it tries all these combinations out for you, so you don't have to. So it makes it super easy to use, which is nice. These two things are great for beginners to get their feet wet, so to speak, with machine learning. And then you can start peeling back the onion layers, so to speak, and cry some more as you go deeper into the mathematics. It took me like a couple of years to really understand what was going on below all of that high level stuff. I actually made a deck called like Machine Learning 101 or something like this. If you Google it, you'll find it. And that's basically my 2 years of aha moments in one deck. And it goes through everything that I needed to understand in order to appreciate what's going on behind the scenes. And with that, you understand how the mathematics works to recognize an object. It's not actually that hard. You just need to know how to add and multiply. It's really easy. But without that, it was really scary. You look at the research papers and it's like, what's going on here? I don't have any understanding of what they're talking about here. But if you explain it simply, it is possible to understand on a high level what's going on. So
where would we find that deck?
If you just put my name and Machine Learning 101 deck or something like this, that should pop up on a search result. I think it's Google 101. Oh yeah, so there should be a link to the presentation itself.
This one?
Google Slides. Yeah, that might be the one. There we go. That's the one. Yeah.
Okay.
So this is like 101 pages of joy. so basically, good bedtime reading. But I've tried to make it a bit fun. There's some videos in there too. There's some nice animations, and it will walk you through from completely zero knowledge of machine learning to having a understanding that this is not magic, at least, and you know what the limitations are and what it's good for, what it's bad for, that kind of stuff. And with that, you can take your first step to then go deeper, hopefully, at least. So yeah.
Nice. Well, this is very cool. So I feel like this is I'm not gonna lie. If any episode was gonna go short, I didn't think it was gonna be the one on machine learning. I thought we were definitely gonna have like a lot to cover. So I actually think that is. I feel like that's actually more and more true of some of the things that I would have considered to be too hard. Like, if you had asked me to build a machine learning driven password protection for a section of a site, like, obviously this is not production ready. We're not going to take this and throw this out into the world and be like, yeah, it's definitely secure. However, the fact that we were able to do this quickly is I think a good signal that, like, this stuff is more approachable than we may have thought. If we want to get into machine learning, we want to start playing with this stuff. It's not, like you said, it's not like advanced math. We're not doing, we're not getting into like advanced computer science here anymore. We're now able to do effectively web dev. And if we need some extra data, we've got tools.
Developers tinkering with a black box, and 99% of the time, you don't need to make your own models from scratch. There will be cases where you do, and maybe you're making a new thing that's never been done before. But some of the kind of things like sound recognition or object detection, these kinds of things are almost, dare I say, solved problems in a way. And you can just reuse an existing model, train it on your own data, and then just use that. And you don't have to like go and build it yourself from the low-level Legos, as I was talking about earlier.
Absolutely.
And with TensorFlow.js, we're trying to make more of these high-level building blocks in these nice, super easy, wrapped-up JavaScript classes that you saw. We could just pass it in a video object. It just knew how to deal with it. So we've done a lot of the heavy lifting there of the canvas stuff behind the scenes as well for you. You can send it a canvas, you can send it a video, you can send it an image. It just works with an image-like object. And it abstracts a lot of the kind of, the onion layers from us. But for the first steps, it's good enough, honestly. And like you can make some amazing things. And just to kind of reiterate here, the invisibility demo we saw at the very beginning, I was using something called body pics for that, which is what our body segmentation model is called. And I made that in just a day. So, really advanced effects can be made using these models. And this is a great site. Muffin, or was it dog or something?
Yeah, muffin or chihuahua. I bring this up. The chat was saying like, oh, you should use like foxes or cats or dogs, and it reminded me of this. One thing that's probably worth talking about in the last couple of minutes that we have here is the limitations of this, right? Because it's not. This isn't something that's just going to work. Like it's not human intelligence. It's trained data. It's
mathematics. We must remember it does not have any intelligence like you and I would have in our human brains. So you show it a muffin, and if you didn't show it this other dog type, it would call it a muffin for sure. But by having that training data available, you can then reduce these biases that might be learnt by the model. So if we have this chinchilla dog and muffins as two separate classes, it will then be able to hopefully figure out the differences of why that's a muffin versus a chinchilla.
I'm honestly like, I'm not gonna lie. If you gave me this list, I'm pretty sure I would misclassify a few of these dogs as muffins.
Right now, and are you like, is that a dog or a muffin? Should I eat it?
We'll end up petting a bunch of muffins, and it's all gonna go poorly. Like, but so like to your point,
eyesight's going as well. So you got to like be very careful there.
Yeah, but I do think that's worth stating again. Machine learning is not intelligence in the way that we would think of it as applied to humans. Machine learning is a mathematical model that is measuring like the distance between pixels or something. It's not necessarily like I know what a dog is. It's I know what images of dogs mathematically look like. And that once that starts to click, I feel like that makes all of this a little less mysterious.
It's more like statistics. Is that I've seen 1,000 images of dogs, and on average, a dog has some of these features that I now know how to detect. And if I detect those same features with the same proportions and same kind of ratios and all that kind of stuff, then probably it's a dog, that kind of stuff. So there are like research papers where you can even like attack machine learning models with like 1 pixel, and you can then make it turn into a panda just by changing the color value to be something very specific. You have to know how the architecture works to do that. It's like not going to happen by random.
Sure.
Very, very unlikely at least. But it's possible to then fool the mathematics such that it comes out with a different calculation. So people who are really low level can figure out how to do that kind of stuff. But once again, more training data helps alleviate these kinds of problems and so on and so forth. And hopefully in the future, better, more advanced architectures can also help differentiate between these kinds of attacks and things like that in the future too. But this is an ongoing research topic, obviously. So,
yeah. Well, I mean, so this is amazing. Let's play this one more time. Like, let's play this game one more time. We are going to unlock a section of the website using our computer vision here. So what we've got is we have the object classification running right now, and it's looking at my webcam. So this is the webcam on my Mac, and it is currently it's seeing me as a person. I need to show it a banana. So I show it a banana. It sees a banana, and we see that light up there. Now it wants to see a fork. So let's show it a fork. Okay, sees a fork. Okay. Now I need to show it a book. Show it a book. There we go. I have now unlocked this section of my website. And to do all of that, all we had to do was write less than 100 lines of code, which is fascinating to me. Like it's just amazing how approachable that is. So for anyone who wants to,
not the machine learning.
yeah, that's fair. Yeah, it's mostly the logic, right? Like the logic of doing the password part, not the machine classification stuff.
Which is like 2 lines of code to import and use for Coco SSD. So yeah, really cool.
Yeah, I just realized I posted a bad link, so let me post a better one. Nope. Twitch just really does not like those hashbang links. That's fine. Well, so you can copy paste that out. You won't be able to click it, and these will all be in the show notes. For someone who wants to take this further and wants to, like, where should someone go from here?
Yeah, that's a great question. There's a few resources to get started. Obviously, our website is like the central point where you can get all things related to TensorFlow JS resources-wise. There's our models on there. There's some tutorials, but API for those of you brave enough to go lower level. There's an API section as well. If you do want to get more deeper and more serious about machine learning, we've written a book called Deep Learning with JavaScript by Manning Productions, I think it is. And if you bring that up, just make sure I've got the right name there. Let's see, that one, yeah. Cool, that's the one. This will take you from zero knowledge. You just need to know JavaScript, basically, but it will assume no prior knowledge of machine learning. And it'll go from very simple things known as like linear regressions, but allow you to predict linear data. So if a house has a square footage of X, what do we think its price is going to be? So very simple model predictions like that, which you can do in just a few lines of code, all the way to the more advanced generative stuff where you can generate images of muffins or something if you want to, and it will just give you endless muffins, which would be great. So all that stuff is possible in this book.
Endless muffins.
Beginning to and also we've got I managed to negotiate a discount with Manning. So if you use made with TFJS without the hashtag, it's made with TFJS, you get 30% off the book or any book on Manning even. So that's pretty cool. So
you say 30%?
30. So yeah, that if anyone's watching and they want to go further, it's one of the only books I know of right now which talks about TensorFlow JS like this. There's also some courses on Coursera from some of our other developer advocates who have touched on TensorFlow JS, I believe. Lawrence Moroney has made a course on Coursera, I believe, which does touch on TensorFlow JS. I'm not sure if it's a dedicated TensorFlow JS course or part of a bigger TensorFlow course itself, but that could be useful for some folk. But I'd recommend the book and the kind of the website as a starting point. And then if you need more of a video-based tutorials, then check out the Coursera stuff. And also Gant also made a tutorial, a course for the more low-level tensor stuff. So tensors, why is it called TensorFlow? Just very quickly, like tensors are simply multi-dimensional arrays with some extra functions added on for good measure. And as I spoke about, these tensors contain numbers. This is all the mathematics that I was talking about flowing to do the machine learning. So basically, these tensors contain lots of numbers, and Grant talks about how to use and manipulate these tensors essentially with his course on the Infinite Red Academy there. It's a great course if you want to just understand the lower level stuff and learn how to manipulate tensors and do various things. And that's useful if you weren't using one of our pre-made classes. Maybe you want to take the webcam data yourself and turn that into a tensor to use with a different model that isn't one of our pre-made ones. Then understanding how tensors work is very important. So yeah.
Very cool. Yeah. Well, so I think this is a really, really fun space to be in. It looks like there's a lot of amazing stuff we can do. And what we did today is just kind of the very, very tip of the iceberg. But it looks like there is a huge amount of additional content if you want to move on and get forward. So make sure that you go and follow Jason on Twitter.
Thank you.
At Jason Mays. Anything else you wanted to add before we wrap up?
Yeah, just one quick thing at the end is please just go and try stuff out. Go try the Teachable machine. In 30 seconds, you can recognize anything in your room. And if you end up making something cool with that, maybe you unlock your garage door or whatever you want to do, just use the made with TFJS hashtag so we can find you on social media, Twitter, LinkedIn, whatever your preference is. And you have a chance to be featured at our future show and tells, or maybe even a blog post write-up to get you more visibility. So if it's particularly cool, we will reach out to you. So yeah,
Excellent.
Keep in touch, and I look forward to hearing from you. Very
cool. So one last shout out to our sponsors. Thank you again to White Coat Captioning for making this show more accessible. And thank you to the sponsors, Netlify, Fauna, Sanity, and Auth0 for kicking in to make that possible. Chat, make sure that you go and check out what's coming up on the show. We have an amazing schedule. I am just so excited. On Thursday, Chris Biscardi, longtime friend of the show, and one of like JavaScript's mad inventors, is going to come and teach us Toast, which is a meta framework for building super performant React based websites with MDX. It's very cool stuff. It's all very modern. I'm really excited to learn about it. Then we're going to go over and we're going to talk to Abina and talk about building Jamstack apps with Gatsby. We've got Prince, one of my favorite people in the world, coming on to teach us Rust. We've got Kelly Vaughn coming on to teach us about building Shopify sites. Emma Bastian is going to come on and we're going to teach her that Taco Bell is bad while she teaches us about building web apps. It's just going to be so good. Like, please come and hang out with us. It's going to be so much fun. I'm getting word that the coupon code is not working. Could you maybe tweet that?
Check into that. Yeah. I'll put something up on Twitter afterwards once I figured out what's going on there. It was working last week, so I'm not sure what's happening.
I also might have typoed it because I was.
Okay.
Yeah.
It should be just made with TFJS, one word, no hashtag symbols.
Is it all uppercase or something?
Just lowercase is fine, I think. Yeah.
Okay. So made with TFJS. Yeah. Try that. See if that works.
Yeah.
Cool. Okay. So with that, chat, thank you so much for hanging out today. Stay tuned. We are going to raid. Jason, thank you so much for hanging out and teaching us today. This was super fun. I'm really excited to see what else we can do with this machine learning stuff. And I mean, on that note, we'll see you next time. Thanks, y'all.
Thank you very much for having me. Cheers.